all three sides are the same. We have an equilateral triangle. So just like we can name triangles by sides, we can do the same thing with polygons. So this would be equilateral. That's a horrible spelling of equilateral triangle there. Wow. Okay, here we go. So for the first idea, the first box here, we're going to describe polygons. Okay, there's two things that we need to know in order to describe polygons, and both of those things need to be met. Both those conditions need to be met. So a general figure of a polygon is sort of over here on the right-hand side. Okay, this sort of generic-looking polygon. So let me introduce the parts to it, right? So a polygon has these edges here, which we call sides, and that's highlighted in blue for you. So those are called sides. And the points where the sides sort of meet, that's called the vertex. So we have vertices, and we have sides. So this is a generic-looking polygon over here on the right-hand side, right? The sides have to be sort of line segments, and the vertices are just points where they intersect. So here are the two important ideas for describing a polygon to determine whether or not a figure even is a polygon. The first one, it has to have 3 or more sides. 3 or more of the sides. So if you look on the right-hand side here, how many sides does this generic polygon have? It has 5. Yeah, you're right. Yeah, I got 1 there. 1, 2, 3, 4, and I have 5. So I have 5 sides. So that's definitely more than 3. And then the second little part. No 2 sides with a common endpoint are collinear. So I wonder why they said that, right? Well, the reason they said that is so that you don't have a straight line with a point on that line. So that's a little side point. So the most important thing is it has to have 3 or more sides, and those sides cannot be collinear. That's the first thing. The second thing says each side has to intersect exactly 2 other sides, 1 at each endpoint. And here's what they mean by that. So if I was to make little red dots over here on the side of my vertex, and then circled them, how many times does that intersect? Well, it intersects twice, right? 1 side there and 1 side there. And if I do that all the way around, notice that it only happens for 2 of them. Sketches of these right here. They don't need to be perfect. They definitely don't need to be perfect, but make sketches, and I have 6 of them for you, right? I have sketches A, B, C, D, E, and F. So what we're going to do is we're going to look at all these different figures here, and we're going to decide, based on those 2 conditions that we just said, whether or not we think these are polygons. So make little sketches. They don't have to be perfect, but label them. All right. All right, we got our guesses down now? Okay. Let's talk about these. Let's see how close we are, okay? All right, I'm going to call on Ivan. Ivan, your name came up on the TV. What's your guess for A, yes or no? Ivan says no. Okay. Let's go on B. And remember, hey, please remember who I call because I'm going to come back to you. B, Justin Smith, where you at? What do you think for B, yes or no? You say yes. Good. Okay, I'm going to ask you to justify your answer later, okay? C, Francesca, what'd you put? Yes or no? Yes. You put yes? Okay. Next one is Michael Van Doorn for D. You said no. Okay, bless you. Bless you. E, Marilyn. You put no? Okay, remember who I called on. And then F, Mandy, what do you think? You put no. All right, cool. Let's go back to A. Ivan, why did you say no? It doesn't look like it? Why not? Why does it not look like it? Hold up. It's got 3 or more sides, true. Maybe it is? You don't know, so you just put no. Okay, well, let's see here. It looks like it does meet condition number 1, right? There's more than 3 sides. How many sides does this thing have? It's got 1, 2, 3. It's got 4, so it meets that. No 2 points are collinear. True. Each side has exactly 2 other sides where it intersects. So what does that part mean? Here's what you can do. You can circle every single endpoint. How many sides go to that endpoint? 2. How many sides go to this one? 2. How many sides go to that one? 2. How many sides go to this one? Is that all of them? Yeah. So they all have exactly 2. Each side intersects exactly 2 other sides, 1 at each endpoint. So what do you think the answer is, guys? Yes. So the answer is yes. All right, there we go. Good justification there. Okay, who did know B? Who had B? Justin, what do you think? Yes or no, buddy? Yeah. Why do you say yes? You got to say why.
It has 4 sides.
Okay, good. Yep.
2 points aren't collinear. And each side for each vertex has 2 sides.
Good. That's exactly right. It meets all of the conditions, right? So it has 2 sides there, 2 sides there, 2 sides there, 2 sides there. Each endpoint. So the answer yes is absolutely correct. Nicely done. Who had C? Francesca, what do you think? Why did you say yes for C? Yep, 1, 2, 3, 4 has 5 sides. Good, yep. Yeah, exactly right. So this vertex has 2 sides that intersect it. So does that one, so does that one, so does that one, and so does that one. So they all are exactly 2. So the answer yes is absolutely correct. Nice job, Francesca. D, who had D? Okay, you said no. How come? It doesn't really have any sides. It doesn't? How many sides do you think? 2 sides? Yeah. This is the weird one, right? We definitely have 2 sides made up of line segments, but you know what? We have a curve here. So if we have a curve, then we cannot call that thing a polygon. So the answer is no. So nice job. You did correct. Okay, who had E? Yeah. Okay, Marilyn, what do you think? Yes or no? You said no. Why? Yeah, each side doesn't intersect, right? We have 1, 2. We have 3 sides, but unfortunately, right here, I only have 1 side matching to that vertex that it doesn't intersect. So you are correct in saying no. Nice job. And then, Mandy, did you have the last one? Yeah. Okay, why'd you say no? I don't know. You just guessed? You just guessed. Okay, what do you think?
Well, because there is more than 3 sides.
There are more than 3 sides. Yep. 1. There's 2. Is this whole thing a side? 3. Could be a side, right? 3 or 4. And then 5 or 6, depending on how you're looking at it, right? Okay, so I'm with you. It matches the first one, but...
In the middle...
Yeah, there you go.
There's the vertex in the middle. There's 4...
Yeah, exactly. We have more than 2 sides intersecting there, so this part is bad. We're throwing that whole thing off, so therefore it's not a polygon. So the answer is no. You know what? We did 5 out of 6 correct. Not bad for the first try. All right, what do you guys think? You guys pretty good at looking at figures and determining whether they're polygons now? Yeah. Yeah? All right, cool. Let's go on to something fun here. I have a table here. So what's an easy way to remember that one? Yeah. Octomom? Octagon. Octomom. Yikes. Okay. All right. All right, what do we call... Jose Guzman, what's a 3-sided figure called? Triangle. Oh, there. What's it called? Triangle. Very good. Good. What's a 4-sided figure called? Alyssa Richards. Can anybody help her out? Not square, not square. I mean, square is part of it, but there's a name for it. There's a real name. Think of the coordinate plane. There are different quadrants. Quadrilateral. 4-sided figure is a quadrilateral. I think I spelled that right there. Okay, 5-sided figure. Think about the government. Think about the government. Who can think of a 5-sided figure? Let's ask Mr. Guzman. Did I already ask you? No. Where's he at? Daniel. What do you get for a 5-sided figure? What do you got? Think of the government. Does that help you out? Yeah, it's called the Pentagon. Has anyone ever seen a picture of the Pentagon? It's a five-sided huge building, right? Okay, 6. Who thinks they have the 6th one? Let's ask the TV. Let's see here. Allie, what's a 6-sided figure called? Yeah, hexagon. Very good. Hexagon. Very good. Ooh, the 7 one. Everybody always forgets this one. Do you think you know it? Centagon? Not a centagon. No. What? Not a sectagon. No. Say again? That's it. Heptagon. Not hecagon. Heptagon. Heptagon is a 7-sided figure. We have octagon, which is 8-sided figure. Anybody know 9? Daisy, do you know 9? Where are you? Ooh, what is it? Yeah, it's a nonagon. Nonagon. 10. Chad. Decagon is correct. And there are a few more, but once we get up into those big giant ones, like a 14-sided figure or a 30-sided figure, we just call that an anagon. An engon. Okay, so you see the highlighted ones? Anyone see the highlighted ones? You gotta memorize those ones. But I'll bet you already know triangle, yeah. Quadrilateral, yeah. Pentagon, yeah. Maybe you definitely know that one, so you really only have to memorize 2 more. All right? So 6 and 7. Hexagon and a heptagon. And 9. No, that one's not highlighted. Just 3 through 8. Yep. Okay, 4th box. This idea of convex versus concave. If you have a highlighter, go ahead and bring those out. It's kind of fun. Here's how you do it. So, what you need to do is take a look at all of the sides. So, what is if I draw one of the sides here, if I take this top one and I extend the side in both directions there, the question you have to ask yourself is, does that line go inside the polygon? No, it doesn't. And in fact, any side that you draw, that you extend out from each side, notice that one stays outside the polygon. This side stays outside. This side stays outside. And finally, this side stays outside. So if all of your sides, when you extend them, stay on the outside of the polygon, then it's called convex. Does that make sense? Now, do you see the difference about this other one over here? Yeah, right? If I extend this side, no problem. If I extend this side, no problem. Does anyone see the side where I run into problems? The side that forms the dent in the side of the polygon, right? So if I extend this side, now all of a sudden, check it out, I am on the inside of my polygon. So we have a name for that. That's called a concave polygon. Someone in the last class mentioned there's like a little cave here, you know, like a little cave. And that's why the person's hiding in the cave, right? Actually, I was the person who thought of that, so. Yeah. So, if you want to think of it that way, too. So, convex versus concave, right? What's the difference between the two of them? You're going to let me know. So who can spit it back in their own words? Yeah.
The concave is when you extend the lines on the polygon and it goes inside.
Do all the lines have to go inside? No. Can it just be one of them? Yeah, just one of them, 2 of them, right? That's all it takes. Is it going to be 2 most of the time now? Is it going to be 2 most of the time? Yeah. Well, yeah. Could you draw a polygon that has 3 lines that intersect on the inside? 4 lines? I think. What if I did this? Hey, check this out. What if I drew this picture here? How many times does that thing go inside? Yeah, that goes quite a bit, right? So check it out. This one does, that one does, this one does, this one does, that one does. So you can draw it quite a bit, right? But it's still a polygon, isn't it? Yeah, it sure is. It's just a convex polygon. So we can describe those two. Hey, let's go back here. Oh, excuse me, concave. Thank you so much. Let's go back over here. I made a mistake. Convex or concave, the first one? Concave. Convex. Convex. Well, not even one, right? Not even one, not even one. Okay, good. So the first one is the only one that's concave because you can draw two lines that go on the inside. The rest of them are convex. Nice job. Okay, last idea of the day is something called a regular polygon. Last idea of the day. So regular polygon, two things happen, right? The first thing, equilateral polygons, all sides are congruent. The second thing, equiangular polygons, all interior angles are congruent. When you have both of these, that means you have a regular polygon. All right, so the question I have for you right now is on the left-hand side. Can you think of a regular polygon you see every single day? What? Yeah. A stop sign. Can you think of another one? A yield sign. Dang, did you guys see this lesson already? Oh, yeah, there you go, right? There are two examples of regular polygons that you see every single day, right? Why is the stop sign a regular polygon? Yeah, because if I were to, let's say, I guess red, right? So all of these sides are the same length, right? So it is equilateral. And all of the interior angles, this angle, that angle, that angle, that angle, that angle, that angle, and that angle, and finally that angle, those are all the same as well, right? So this is a regular polygon that we see every day. Same thing with this one. So could you describe this? How many sides does it have? So this is a regular octagon. Isn't that cool? We can have all these different ways of describing things, right? Regular octagon. What would this be? A regular triangle. Very good. A regular triangle. Because supposedly we have all three that are the same. So we have three sides that are congruent. And every side inside there, every angle is also congruent. All right, we did a lot today. We did a whole lot today. We started off by talking about polygons, describing the two things that have to happen. Then we took a look at some figures to see which ones are based on those two conditions. Then we had some fun talking about the names of polygons, memorizing a few of those. This idea of concave and a regular polygon. Two things have to happen. Okay, take a moment, write down your summary. Take a 1 minute.